Okay, so I'm gonna go through this so that you can get an idea of the types of questions. So there will be some IEPAC naming, so picking from a list of options. Usually what you'll see is there are some kind of tricky answers that sound really correct, but they are definitely not. Remember, you're going to be taking this on Examity, so you can't Google the correct answer or Google the structure and hope that you get it or that you can find it, or Google the names, which I think a lot of you tend to do when you're doing homework. If you kind of do your homework with help, you might want to consider doing your homework on your own for the next couple of days just to get yourself a little more comfortable with the material. Notice there are some conceptual types of questions. You're going to see a lot of these because those are the types of questions that are the easiest to put as online questions and not have to worry about students finding alternate ways of coming up with the answer, if that makes sense. You'll see a lot of questions like this where you're either given a starting material and a reagent and you have to figure out the product, or you're given a reagent and a product and you have to figure out the starting material. We're actually going to go through this question because this is a good one. Or you might be given a starting material and a product and you have to identify the reagent that would actually be able to make that product. A lot of questions like this, conceptual questions. The attendance code is in the chat. More identifying common names. Notice this is another conceptual type question about the electrophilic aromatic substitution mechanism. Questions about whether or not you understand what a Grignard reagent is. Seeing if you understand generally the reagents. A lot of times students memorize like specific reactions, and so I tend to ask questions like, a primary alcohol reacted with PCC will form a blank, because that's how I've asked you to actually learn the material. So I tend to ask questions that reflect the way that I asked you to learn it. You do have to be able to recognize reaction conditions. So notice like here it says PCC. So I didn't give you the individual pieces, but here you were given the individual reagents that make up Swern. When I gave this test in person, the #1 question that people asked me as I was walking around the room was, what are these reagents? Or someone would ask me like, is that Swern? And I would say, okay, you were supposed to learn that. So, you know, I'm not going to give you the answer to something that you were supposed to learn on your own. Okay, so anyway, more conceptual questions, identifying names. This is a really common type of question. You've seen this in your homework. You'll see questions like this on the exam. Order the carbocations below in decreasing order of stability. The #1 mistake that students make is reversing the order. I tend to not put the reversed order answer anymore because if you reverse the order and then you see the correct answer, like the one that you think is correct, you won't go back and rethink that. So I tend to not put that. I believe this one does have the reversed correct answer as an option. This is a really common type of problem. This type of problem is especially tricky if you have not spent any time using organic terminology as you work through problems. If you are tuning out during my class, or you're tuning out during SI, or when you're working on problems with a friend, you're just kind of like, well, this one has that double bonded oxygen, and we're using this PBr3, and like you're not using any of the actual terminology, then a question like this is going to crush you. I got a lot of questions about what is an aqueous acid workup. I use that terminology all the time in class to just, you know, identify using H3O plus or like aqueous acid as a secondary step. So you need to know those words because I use them all the time. Your SI probably uses them all the time. You should be using them as you work through problems. And so this type of question is checking to see if you are actually working through these problems on your own and thinking about them on your own and using that terminology. This is a very typical question. You're going to get things like this. What is the major product? There will always be answers that look correct that are not. So my suggestion for this one is when you have a question like this, ignore the answers entirely. Draw out the starting material, draw out the reagents, work through the mechanism if you have to, figure out your own answer, and then go find your answer in the products. If you just look at the products and you're like, oh, which one of these? Every single one of these are ones that I've seen students draw on quizzes. So I picked these because they look right. So you have to go through and actually figure out which one is correct. So I would draw your own product first. Same for this one, draw your own product first. That was the #1 hang up on this question is students go through and they try to figure it out by looking at the answers. That's not going to work. Same thing here. I really like this type of question. You'll probably see a question kind of like this on Canvas. It says, circle the diene and dienophile that when combined would react most quickly in a Diels-Alder reaction. So this is asking you to pick the most reactive diene and the most reactive dienophile. The #1 question that I got from students was, well, which ones are dienes and which ones are dienophiles? Do I pick one in the top and one on the bottom? You're supposed to recognize that the top row is all dienes, the bottom row is all dienophiles. If you can't recognize those things, then you're not prepared for the exam. I love to give some freebie points of provide the common name. I asked you guys to memorize these. You're supposed to know them for doing IUPAC names. So every once in a while, I give some freebies. I also give some freebies in the form of what is the pK of this proton, things like that. Because we're about to get to a point in the class where if you don't know the pKs of things, you're going to be in a lot of trouble. Now, this type of thing we won't be able to do as easily because there is no structure drawing tool on Canvas. So what it'll be instead is products that are easily named, if that makes sense. So like if the outcome could be named pretty easily using IUPAC nomenclature, then I might ask you to name the product. So you won't actually be drawing the product for me. And I realize that that's asking you for a couple different levels of things there. There won't be a lot of questions like that because that depends on you both coming up with the correct structure and then naming it correctly. And I can't check your intermediate. We will not be able to do synthesis written out on Canvas. What we might be able to do is I can ask you for a list of reagents. So we'll go through this in a second and I'll show you what I will be able to ask you on Canvas instead of doing a regular synthesis. This doesn't mean that you shouldn't practice synthesis because you definitely should. What I normally do is I give a couple synthesis options and then you do one of them and tell me which one you want graded. So these are the types of questions that you're going to see on the exam. It's going to be largely multiple choice. Most of them won't be as simple as what is the IUPAC name of the compound below, because I know that students still cheat even using Examity. There are YouTube videos that teach you how. I've watched those YouTube videos and so have the Examity people. So if you try some of those things, they are looking for them. Anyway, so because of those possibilities, I tend to not give questions that can be Googled, basically. Okay, are there any questions about the structure of the test? I realize that was kind of rambling, but I wanted to show you some things first.
So because this is going to be multiple choice, how many questions are there going to be in the test total?
I haven't decided yet. Usually there's about 30 questions total. So some of the questions will be things that you should be able to answer fairly quickly. Allison asked how far in chapter 15 is the test, just through electrophilic aromatic substitution. So the things that I've posted videos about, and I did post some videos on Sunday that support the practice problems that we did on Friday. So if I've posted a video about it, it will be on the exam. So yeah, it's just.
I'm sorry, is the exam the 50 minutes long or longer?
50 minutes. Yeah, I can only give it to you for the duration of the class period. If you have a class beforehand, please let me know if you're planning on coming to the Zoom exam. Okay, I want to work through some of these questions with you guys. I'm not going to work through the nomenclature ones. I'm going to post this video later, so if you wanted to go back through some of these questions, I'm not going to post this exam because this is my hard work that I don't really want up on the internet, but this video is going to be up, and so you will still be able to see some of the questions anyway. I'm just not going to post it in Word document form, but there is a practice test up. I see a question. For the videos, are we expected to be notified through YouTube for newer videos? You can be, or you can check the Canvas modules kind of regularly. I posted them in the modules as well as just updating them to YouTube. Subscribing to my YouTube channel is by far the easiest way to make sure that you get the information that you need.
You said a practice test was uploaded. Where's that at?
It'll be under resources. I haven't linked it yet because many of you haven't done the homework. I tend to put practice exams up at the last minute just because I think they're the last thing that you should work on. Okay, so I want to go through this problem with you guys. We're going to do a couple things with this. First of all, we're going to talk about how the chemistry works, but I also want to talk about taking a multiple choice exam in a smart way, because there are ways to get through a multiple choice exam, I guess cleverly is the word I'm going to use. So when you're doing an exam like this, the easiest thing to do at the beginning is to always go through and identify the answers that cannot possibly be correct. And you do not even need to actually look at the reagents that we're using in order to do that. So this is basically a which compound could be oxidized to give you this, right? So let's look at these compounds. What type of alcohol does this have to be in order to be oxidized into a carboxylic acid eventually? If you're going to have alcohol.
Primary.
So answer A is already just out. If you oxidize answer A with literally anything, it could be PCC, something really mild, or it could be potassium permanganate, you're going to get two ketones. So compound A will not work. Compound B has a secondary alcohol here. Compound C has a ketone. Compound D has a secondary alcohol. Will all of these make the ketone that you need when oxidized?
No.
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 Can a ketone be further oxidized?
No, a ketone can turn into a secondary alcohol.
It can be reduced to a secondary alcohol, but
Reduced, not oxidized, yeah.
Yeah, in an oxidation, it's stuck here. So, I mean, by the time that you've identified question A, you've already kind of figured out the answer. But I had a lot of students pick this one for their answer. And so I want to talk about this real fast. So we've seen primary alcohols get turned into carboxylic acids pretty regularly. But what about aldehydes? What do we know about oxidizing aldehydes?
If there's something stronger, then it can go further.
Right. So as long as you're not using like PCC or SWERN, you can get to a carboxylic acid. So that was, I think, the major misconception here. So A is the correct answer. And also, I really, really, really regretted that because it says A, which of these cannot be compound A, and then the answer was A. So I think, like, even though that's bizarre logic, I think that might have hurt some students. The next one that I wanted to go over. Okay. So question 9 and 10, this is a really common type of question from me. I'm obviously going to have to get really creative since I'm giving you that answer or these questions right here. I'm going to have to come up with some way to still ask this type of question. But go ahead and think about this for a second. Nobody say the answer out loud. I want you to come up with the answer on your own to the best of your ability, and then we'll talk about it out loud. So you have a primary alcohol, and you are reacting it with PCC. Think to yourself what functional group will form. I'm going to give you about 20 seconds to try and come up with this. Okay, if you struggle with words, there is nothing wrong with drawing out a primary alcohol for yourself and trying to draw out the product so that you can identify the functional group. What functional group will form when you react a primary alcohol with PCC?
An aldehyde.
Another question that I got while giving this exam in person is, what is pyridinium chlorochromate? I told you guys that you needed to know the names of the reagents and not just the shorthand. But also remember that a lot of these, you can use context clues, right? If you're looking at this, like all of these are oxidation products except for ether. So you can probably recognize like this is probably an oxidizing reagent, and then you can think like which one doesn't match the most in my head, right? Okay, so same thing here. If you can't come up with the answer in your head, draw out the secondary alcohol, draw out the ketone, and then think about it. I'm not going to give you the answer to this one because I think you guys can come up with that one pretty easily. I also like to ask this type of question. Notice these are all conceptual. Okay, let's go through number 14. Order the carbocations below in decreasing order of stability. So this means most stable to least stable. I'm going to go ahead and put you into breakout rooms for this. So go ahead and screenshot it or draw out the 5 carbocations real fast. I'm also going to find Anne. There you are. Oh, I can't make you a co-host from here. Okay, and you should be a co-host. So
yes, I got it.
Go to the rooms. Okay, and then we're gonna bounce around the rooms and check on you. And everybody should be working in their breakout room. Okay, so let's go back to this. What answer did we choose the most? Are people?
We chose C.
It's kind of hard to tell what some of you guys are saying.
C.
I think
C.
I want to go through real fast and just talk about like, what if you were doing this and you were unable to like come up with a solid answer? Like you couldn't come up with an answer that actually matched any of these. I would not use these to dictate your answer. I would try to come up with an answer and then try to match it. If you were unable to get it to actually match, let's go through ways that you can actually like eliminate things. So which one by far is the least stable?
5.
5. So you should automatically remove that. It's primary. There are no double bonds. There's nothing allylic. There's nothing conjugated. 5 is by far the worst option. So you should not be considering anything that has 5 at the front or even like somewhere in the middle. It is by far the worst. Unfortunately, I gave you 2 that have 5 as the last answer. The next thing that you could do is try to identify the best. And I think a lot of you guys had some trouble with this. You can also try to identify the second worst. Did anybody have like an easier time finding the strongest one or the weakest ones?
So I know allylic is the strongest, but we were a little confused between 1 and 2 because we realized 2 would be better than 1, but we were confused why they weren't like together in order.
Okay. So yeah, there's some kind of tricky stuff here. So 1 is allylic and it's conjugated, so it is stable, but there's no place where it can be tertiary. There is a place where it can be secondary. If you look in your textbook or even online, there's always kind of iffiness as to whether it's better to be secondary and allylic or tertiary. So I just kind of, I put 4 in front of 1, which I kind of regret. That's why I have you guys pick between options instead of writing it out. But one of the trickier ones is that most people don't recognize that 2 has a resonance form. Where you can put the double bond over here and the carbocation here. So that's what makes, sorry, that is a poor drawing. That is what makes 2 the highest option. So that puts that there. The other thing that can be really helpful here is recognizing that even though there's a double bond here, the carbocation can never be in conjugation with it. The attendance code is in the chat if you scroll back. So this one is your second worst option. And there's only 1 answer where it was put there. So these 2 can help you solidify that. Whoops, sorry, I accidentally clicked something with my hand.
If that carbocation on number 2 was in a different position, I mean, obviously that would that change the stability in terms of the strength of how that is?
Do you mean like if it were like here?
Yeah, or I mean, it looks like it's the same. I guess because all of those are like the same thing, right? All of those positions would be like the same thing, right?
Mm-hmm. Yeah, so this one would also have a resonance form.
So no matter where that would be on the end, it would be like kind of the same resonance form after.
It wouldn't be the same resonance form necessarily. Geez, I'm so sorry. I don't know why that keeps doing that. So you would end up with a double bond here and a carbocation here. So you'd have
okay, yes, yes.
double bond.
Would that change the order in terms of 2 and 4, or would that mean just because it has resonance form, it's the most stable? Just like in general.
The resonance makes it more stable.
Okay, I wasn't sure because like you said in the book, it goes back and forth. So
yeah, I tend not to make you guys choose between those, which is why I made it very clear that these 2 were at the end.
Okay, thank you.
Yeah, I try not to be so wishy-washy. This test question is actually a little more wishy-washy than I like to be, which is sad because I wrote it myself. Okay, let's go through this question. 1-butanol is reacted with phosphorus tribromide, PBr3, followed by magnesium metal in ether. Acetophenone is added to the reaction, followed by an aqueous acid workup. What is the resulting product? So in order to answer this question, you have to be able to draw all the structures that are mentioned. So the first one is 1-butanol. You need to be able to draw the correct structure. And then acetophenone is another one that you were asked to memorize. So those are the two structures that you need. When 1-butanol is reacted with phosphorus tribromide, what do you make?
Halogen or
What would be the name of the compound that you would make?
1-bromide, 1-bromo.
1-bromobutane. Okay. So then it says followed by magnesium metal in ether. So that means that you are taking the 1-bromobutane that you just made and reacting with magnesium metal in ether. What are we making here?
Grignard reagent.
Yes, we're making a Grignard. Okay, and then the Grignard reacts with acetophenone. I realize I kind of ran out of space here. And it's followed by an aqueous acid workup. So this is step 1, and this is step 2. So aqueous acid workup just means you're following it with aqueous acid. So which product most matches this?
C.
C. So a couple things I want to point out about the answers that are provided. You were only given one equivalent of the Grignard, and then your ketone has this methyl group here. So any answer that does not have a methyl group in it needs to be crossed out, because when you do the attack with your Grignard, even if you can't picture it with the Grignard immediately, what you should be able to recognize is that if I attack this with any nucleophile, that methyl group would still be there and I would be making a tertiary alcohol. So this is knowing that a ketone plus a Grignard equals a tertiary alcohol. So you need to find that methyl group. C is the only one that actually has it, but E should be crossed out because it wouldn't have enough carbons. It also doesn't even have enough carbons from the Grignard. Notice there are 3 carbons here. So E just isn't even close. Both B and A still have a ketone, so get rid of B. A doesn't even make sense because the ketone has been removed from the benzene ring. It's not even in the same spot anymore, so don't pick that. And then between C and D, this is just you knowing that the Grignard only added once and that the methyl group is not going to go away. So you pick option C. So this one you can do a lot of narrowing down of answers just by kind of knowing the chemistry a little bit. Do we need to go over this 1,4 addition problem?
Yes.
Okay.
I just had a question on how are we supposed to answer, is the test administered online and then we just do it like with you on Zoom? It's administered online, but we just check in with you on Zoom. Is that correct? So we're able to answer online, like, because that just clicked with me, like, how am I supposed to answer this with you?
You're going to be taking the test on Canvas.
Oh, okay, okay.
So what is the major product formed in the reaction below? So are there any that we can easily get rid of?
C,
C. Yeah, why can we get rid of C?
because you're gonna break that pi bond, and then I don't know where the other pi bond disappeared to.
Yeah, so like basically it left an alkene in a place where you shouldn't have been leaving an alkene. And then also like if this is a 1,2 or a 1,4 addition, then you would either be putting hydrogen here and bromine here and getting rid of this alkene. That would be a 1,2 addition. Or you should end up doing a 1,4 addition, right? So the alkenes would not end up still here. So C is weird because it has a 1,2 addition with the alkene still in the middle. Yeah, Alex identified the E is also weird because it leaves an alkene in the 1,2 position. And then you have A, B, and D. So this is HBr in heat in a conjugated system. When it has heat, is this a 1,2 or a 1,4 addition?
1,4.
1,4.
1,4. So we can also get rid of A and B really easily, right? Because it left an alkene in the 1,2 position and an alkene in the 3,4 position, right? Those are not possible. D is literally the only possibility, the only one that even kind of makes sense. Now, if you wanted to actually work through the problem, which I highly recommend, there are a couple ways that you could approach this, I guess. So you want to end up with the most stable carbocation, right? How can I get the most stable carbocation? Let's go ahead and label carbons as like A, B, C, and D. Where should I put the proton in order to get the most stable carbocation?
In the tertiary position?
Is it D?
Well, where should the proton go though?
D?
We don't want to
Or
put,
no,
Oh,
oops, sorry.
The least substituted?
The least substituted.
yeah, so you could have this pi bond pick it up. To give you a substituted allylic carbocation. And then you would have the resonance form. With the tertiary allylic carbocation, and this is the one that would lead to the product that was drawn.
So just making sure I understand you right, the hydrogen does go to the least substituted, or?
Yes, the hydrogen should go to the least substituted because you want the most substituted carbocation. You could,
Okay,
so the reason that you're not going to put the proton, oops, sorry. Why? The reason that we're not going to put the proton on carbon C and put the carbocation on D is because that would not be following the 1,4 addition. That would not give us an allylic carbocation. So if we had protonated carbon C, we would have ended up with this carbocation, which is not allylic. Okay, so that's how you get to product D. Do you guys want to go through this one?
Yes.
Okay.
Yep.
So we have a Grignard reagent and we have a terminal alkyne. what is going to happen in the first step?
The Grignard's gonna want to go and attach to, or the hydrogen is gonna, and then the hydrogen is gonna give the proton or the electrons to the allele. Is that what it's called?
Yeah, so you're going in the right direction. So the Grignard is strong base, right? So we are going to be deprotonating the terminal alkyne, putting the electrons on the last carbon. That makes an alkynide anion. So after step 1, we have this guy plus ethane. Jeez Louise, sorry. We have this plus ethane because oops, that was too many. I was trying to draw a line to the hydrogen that we just added. Okay. Okay, so why did we produce this? What was the point?
So that it could react with 2 and attach itself.
Right. How is it going to react? What term do you use to describe this?
The anion?
Yeah, what's its role in the reaction?
It's nucleophilic.
Right.
So you're going to have a nucleophilic attack.
Right. It's going to attack the epoxide. It doesn't matter which carbon because it's
symmetrical.
Mm-hmm. Okay, so that's what's going to happen in step 2. Let me see, where can I draw this? I guess I'm going to have to erase the arrow that I just drew. So this is definitely an area where students start to add and gain carbons. So be really, really careful. This is the bond that was just made. Right, there's a carbon atom right here. And then I would number the carbons on the epoxide if you know that you're the type of person who tends to gain and lose carbons. So the carbon that's right here is carbon number 2. So it's going to have a methyl group coming off of it, which is carbon number 1. It's also going to have carbon number 3 and 4. And what else do we need to put on here?
Oxygen.
Right, what?
On number 2.
It's not on number 2 because we...
Oh, no, it opens up on number 3.
Right. So we're making an O- here. The last step is an aqueous acid workup though. So we are
protonating the oxygen.
Right. Sorry, that says hydrogen. Okay, so then we can go and find it. It looks like E. The number 1 mistake of people who got really, really close on this one was this, because they didn't notice the ethyl group here. Okay. So it's 10:49. We don't have a lot of time here. The only thing that's not really on this test that will be on yours is aromatic substitution. I want to show you real fast what I'm going to expect from you in the synthesis. And if you have to leave, I understand. I'll post this video later. But in the synthesis things, what I'll probably do is have you write out in a short answer your reagents. And I know that's kind of tricky to write out like subscripts and stuff on Canvas, so you don't have to do that. But let's say, ignore the actual synthesis here. I'm just going to make stuff up right now. Let's say that you work through the synthesis problem, and in your first step, you want to add 0.1 molar H2SO4. You can just write out, 0.1 molar H2SO4. And then, your next thing, maybe you want to add, I don't know, I can't even make up stuff, PBr3. Just write out your reagents in a list form. This is going to be kind of nice for you because you won't have to draw out the reactive intermediates. But what that also means is there won't be a lot of partial credit, because when you're not drawing out the intermediates, it's harder to give the partial credit. So if we do a synthesis, it'll probably be one that has like 3 to 5 reagents maximum, and you would just have to list them out. And, I'm not going to be picky if you, want to use decimals as your list, or you want to do one, however you want to do it. It's going to be graded by my grader in short answer form anyway. So that's what I'll be looking for synthesis.
Are the short answers typed, or do we actually draw it in?
They'll be typed. There's no
Okay.
to draw stuff on campus.
So, okay, just want to make sure. And so if we do it doesn't matter. Okay, I see what you're saying. Cool.
Yeah. So the system is not going to grade it. It's going to be graded by a person. So as long as it's legible, you're fine. As long as it makes sense.
Cool.
And I'll give you guidelines in the directions of the exam. When we leave here, I will post stuff on Examity, or how to sign up for Examity. I'll post directions for that. And then I do have office hours today at 12:30. So if you need some help, you want to come ask questions, please do. I also have office hours on Tuesday. I can't remember what time, but it's up on Canvas. I will not have office hours on Wednesday because you have your exam. And then there's no class on Friday because we won't have learned anything new. So, okay, that's it for today. So if you need to go, you can. Yes, my office hours are linked. If you go to Canvas, there's the Zoom links link. So you can click that button and then you'll see links to everything.
I just have a quick question. You said you posted more videos on Friday. Those are also on the test, correct?
Yes. So it just covers the type of material that we worked on Friday.
Okay. So the directing groups and stuff like that?
Mm-hmm.
Okay. Thank you.
Mm-hmm.
Thanks for the review.
No problem. I hope it helps to see what types of questions I tend to write.
Yes, thank you.
I have a question. So for the last one we just worked out, you said it was kind of hard to do partial credit for that. But say if we have all the right reagents, we just put it in the wrong order.
Wrong order won't get you credit because it wouldn't create the right thing. But if you got the first 2 steps and then you went really far off, you would get credit for the first 2 steps. But I never give credit for out of order things in a synthesis.
Okay. All right. Thank you.
Mm-hmm. And yes, Rudy, the video will be posted today. As soon as it finishes downloading, I'll upload it.
For the chapter 15 homework, I just stopped at where we're at in class, because all of it's not going to be on the test, but it's also due in 6 days. So do we just?
I'll have to extend it.
Okay. I just wasn't sure if I needed to go through and try to.
Oh, no, I'll extend it because we didn't get to nucleophilic aromatic substitution, but we're also ahead of our schedule, so.
Yeah. Okay, I just wanted to make sure.
Okay.
Thank you.
All right, thank you. All right, any more questions?